So on the CentOS side, we provide a solid platform. That's kind of our bread and butter on the x86-64 architecture. We've been doing it for over a decade now. And that's the experience that we want to bring both to developers and to the final end users for the ARM platform. We want it to be simple. We want it to be boring. You're not running a distribution to do something exciting. You're running a distribution so that you can develop the software to do something exciting. I mean, when I look at a piece of ARM hardware, I say, yay, I got CentOS running on it. I'm happy. That's not where you're happy. You're happy because you want to run something on top of the distribution. So let me be happy. Let me deal with all the boring stuff for you so that you guys can go do other things. That comes down to the user experience. It shouldn't necessarily matter if it's x86-64 hardware, if it's Cavium gear, if it's soft iron gear. In a data center, that user experience needs to be the same across the board. If you're changing that up, then you run into little idiosyncrasies that an admin has to plan for, plot for, and will usually start cursing about. So that's an area where you don't want to go. The positive side is if you have a consistent interface across the board, no matter what architecture it is, you get to take advantage of the common tool sets all the way across. So if they're used to running Ansible and CentOS on their x86 platform, and you can come in and say, hey, here's this ARM box, it's faster, it's better, it's got lower power requirements, whatever, you're not competing with the whole stack. You don't have to tell them to replace everything. You're competing chip for chip, and that's it. So I skipped ahead of myself a little bit, but basically keep everything, let me handle the boring stuff. This is what I want. I want the operating system to be boring. It shouldn't move out from underneath you. It shouldn't give you any surprises. Let me handle the boring stuff. Did you get your picture yet? All right. Again, channeling my inner John Masters. The little tiny voice that whispers in my head when I'm trying to go to sleep. So a little bit of history for CentOS on ARM. About 3 years ago, we tried to do this once before. This was before the EL7 codebase dropped. We tried to do it with EL6 codebase. The Calzada folks were great. They gave us some hardware. We tried to make it all work. And we got it running. But it looked nothing like the x86 platform. And that just ran on Calzada hardware, and that was it. Because once we tried to pick it up and move it to another V7 platform, all of a sudden U-boot was different. There were different custom requirements. It wasn't anything we felt comfortable shipping. It ran, and we wanted to just kind of take it out back and shoot it. It should never have seen the light of day. So we looked at that and decided, no, we were never even going to speak of it again. It was something we didn't want to do. Nothing against the hardware, just it wasn't that consistent user experience. So now, we began with an APM board. If Applied Micro's in the audience, thank you for the donor hardware. That saved me from fighting with the virtual implementations and waiting like a week for GCC and friends to build. It's much nicer on Iron than with other things. And we ran essentially 4 major iterations of the build cycle to get everything through and cleaned up. Realistically, it was probably closer to 50 or 60 build cycles because there are individual packages that take tweaks or different things have to be built in different orders. But essentially, there were 4 major iterations. And we were able to piggyback a lot on what Fedora had done in the Fedora 19 realm and then build from that into the EL7 code base. Beginning in, I want to say June. June, we had our first alpha. About a month after that, we announced the first beta. And then at the beginning of August, we announced our gold release. And that's where we are now. It is out there. It is released. Every time we have an update on the x86-64 side, we push that update on the ARM side. It passes the same testing that we do for x86-64 on ARM, so everything that we're doing to validate the distribution works seamlessly no matter what. So for us, that's been very nice. And for Cavium, Applied Micro, AMD, thank you guys for the hardware. These are the platforms that we've tested on initially. We're working with HP to try to get into their Discovery Lab so we can validate it on the moonshot. But since it's based on the X-Gene chipset, I have every confidence that it will just work. The other side to this is we're running, to some extent, dual life cycles. We've got, how many of you in the audience are familiar with CentOS? x86, okay, so most folks know where the code base comes from. We have 2 release schedules because we want to follow our upstream code base very closely. But that doesn't get what everybody wants or what everybody needs. So what we're doing on top of that is offering a little bit of a choose your own risk distribution where you can enable additional repos for targeted specific things. So example, one of our repositories allows you to have Zen virtualization support. And Stefano, raise your hand. Stefano will be giving a talk a little bit later, actually demoing Zen on ARM64 on CentOS. So we have that working. Additionally, as John was talking about, the primary boot method is ACPI based, but that doesn't apply to every vendor that we've talked to. So you can, if you want to, run a newer 4.2 based kernel that does do device tree. We are accepting some patches as long as there's a good faith effort to make sure that it's upstreamed first and we can see that, hey, they threw this patch out on the kernel mailing list. We see it going through that process. That's great. If it hasn't been quite approved and you're willing to help us maintain it, we're fine with pulling some of that in. If you're a manufacturer and that's something that you're interested in, feel free to ping me on that. So for a basic distribution structure, and I keep talking ahead of my slides because I forget to push the button. Basically, we have parity with our upstream vendor. We've got the base OS, we've got the base operating system, we have all the updates, and then the experimental features for Docker, Kubernetes, all of the fun, exciting things, Zen, that you want to see on ARM. OpenStack works. We just haven't got it officially packaged and released yet. That'll happen in the next, probably next week or two. So that's sort of an overview for where we are with the distribution right now. The feature repositories that I was talking about, enabling Zen, enabling OpenStack, storage through Ceph and Gluster, a lot of the different special interest groups on the x86-64 side, we're just bringing over to the ARM side. We're not really giving them a whole lot of choice in that. It's kind of nice. Essentially what this means is we're bringing the ARM hardware into our community development space. So community members will be able to trigger build jobs on our hardware. They'll be able to trigger CI jobs on our hardware. So this will be another place if you don't want to have it exposed or in a completely public environment, you're able to do that through some of what we offer as well. And again, adding into CI or build system, the SIGs. So what this gives you is essentially a distribution that has a very long lifespan. And when I say very long lifespan on the x86-64 side, it's 10 years. We've run several iterations through with CentOS 2, 3, 4, very soon 5. I can't wait for that to die. But we're planning on doing the exact same thing with ARM. So as this grows and as the ARM v8, ARM v8a, and the future iteration server chips come out, we will support them for just as long. So you don't have to worry necessarily about that life cycle, or if I push an update, is it going to break? Do I need to re-roll the OS completely to add a patch or anything else? The installation works just the same as it does on Intel chipsets or on traditional computing. And our license is GPL v2. So if you're a hardware manufacturer and you're not changing anything up, you're not swapping out the kernel or anything else like that, you're welcome to just download it, install it, ship it on your hardware. We're fine with that. I want more people using the software that we put out because that means more people are doing the development our way. It's just back to me telling people how to do things, and I like this. And essentially that, again, to hit on this another time, it allows you to take advantage of the existing tools, the existing infrastructure that a lot of enterprises have in place, be it Puppet or Chef, all of their automation tools. Because the distribution is the same across the board, because it looks and feels the same across the board, everything is already there. So for the chip manufacturers in the room, you're basically just allowing your hardware to compete against their hardware. It really offers itself up as an easy way to do things instead of coming in to tell them, hey, here's this thing, but you have to rebuild everything you already own. So with that, does anybody have any questions? We have some goodies that I can throw to people in the audience to, help kind of engage. I don't mean throw completely, but Stefano's got a bag full of ARM chips or USB keys with our live disk on them. There's some stickers. I've got some lanyards. I'm happy to throw things at the audience. Who's got questions?
No, I'll take the disk.
We can do that.
Very interested in CentOS, so who's got questions for Jim?
I did intentionally leave a demo out of this, one for two reasons. The demo box that I have at my house stopped responding to SSH this morning, and I need to figure out why. The second reason is running an OS is really boring. And I kind of like it that way, but the neat stuff is what Stefano has to offer and what you guys have to offer in the audience. What you do on top of the distribution is what matters. So that's what I want to hear from you, is what you guys are doing with us or what you guys could do with CentOS. So please, by all means, questions, engage. I burned through this too fast, so help me fill my time. Yes?
You've been here an hour ago also touring. What sucked most when porting stuff over to version 8 and so forth? What were your pain points and problems? Was it just building the packages? Did you have to do some extra stuff? Was there something missing?
The initial, when I started with 7.0, there were some things that needed patches. For example, the tests that were involved in the JDK patches initially had a kernel check in there to say, hey, am I building on the 3.x kernel? Well, I wasn't. I was building on a 4 kernel. The problem was everything built, and I had to wait for the entire JDK compilation to go through. And then the tests started happening, and then the test fails because it's the wrong kernel. So it's, hey, I just burned an hour sitting here watching OpenJDK compile, only to see it fail on a test when I know everything built just fine. There were several packages like that, not to call them out by name, Atlas or glibc or a few things like that. In the 7.1 code base, a lot of that was cleaned up. And a fair chunk of that was due to Red Hat pushing RELSA and trying to get some of that code prepped and ready. I was able to pull some patches in, or actually they dropped a ton of packages in our Git repository for CentOS, and I was able to pull other patches from Fedora. So a large percentage of what I had to do was sit back and wait. There were maybe a dozen packages that gave me some problems, and a lot of that had already been solved upstream. So it was just me going through a mailing list, finding the right patch that I needed, pulling that patch in, and the majority of that's been solved.
Any other questions? All right, please everybody give a round of applause to Jim Perrin.